everything you need to know about the ECM motor. ECM motors are a recent advancement in HVAC technology that is gaining popularity. First introduced by GE in 1985, ECM motors are an energy-efficient alternative to basic PSC motors. Though ECM motors are still considered an upgrade, they will soon be standard in all furnaces. An ECM, electronically commutated motor is a brushless DC motor that uses electronic controls to regulate its speed, torque, or power output without external devices or sensors. Standard PSC permanent split capacitor motors turns on and off at constant speeds. How does ECM motor work? An ECM motor relies on a microprocessor to calculate the motor's speed and torque and maintain airflow. Magnets drive an ECM motor. The motor's rotor is a permanent magnet. A series of electromagnets or coils line inside the motor's stator. The controller applies power to sections of the coil to energize it. The opposite poles of the rotor are attracted to the coil section, and the rotor rotates. Then the next coil section energizes to draw the rotor and turn it. This process occurs along the coil's areas again and again in quick succession to spin the rotor. Types of ECM blower motors. Constant torque. Maintains the same amount of torque regardless of the static pressure in the HVAC system. Increases power to maintain the same torque when the pressure increases. Commonly used in air handler blowers. More efficient and economical than other ECM motors. Variable speed. Also known as a constant airflow motor or a constant CFM motor. Maintains the same amount of airflow regardless of the static pressure in the HVAC system. Increases torque and speed to maintain the same airflow when the pressure increases. Used in high-efficiency furnaces and air conditioners. Constant speed, also known as a constant RPM motor, maintains the same speed regardless of the static pressure in the HVAC system. Increases torque to maintain the same pace if the airflow is restricted, typically used for AC condenser fans. Variable speeds. ECM motors can vary their speed between 0 and 100%. Speed adjustments can be permanently programmed into the motor or applied by the controller when it senses adjustments are necessary. Energy savings. ECM motors are 65 to 75% efficient depending on the output. PSC motors are about 45% efficient. The higher efficiency of ECM motors yields lower energy costs, lower maintenance, and longer lifespan. ECM motors contain true ball bearings that don't require regular lubrication. ECM motors have longer lifespans, about 90,000 hours or 10 years of service. Increased comfort. ECM motors run longer cycles at lower outputs to maintain consistent temperatures, avoid sharp increases and decreases in temperature, remove humidity, and prevent temperature stratification. Better air quality. HVAC systems filter household air while they run. ECM motors' longer cycles bring about more extended periods of air filtration that provide better air quality. Although ECM motors are superior to PSC motors, they have some disadvantages. The top drawback is the cost. According to Home Guide, an ECM blower motor costs $600 to $1,500, while a PSC blower motor costs $300 to $1,100. Additionally, the motor's complexity increases the chances of something going wrong. If any part of the motor fails, the entire HVAC system will be down until the motor is repaired or replaced. The issue can't be bypassed to keep the system running. EC motors are programmed at the factory, so they can't be switched out with a new one off the shelf. The HVAC system will be inoperable until another motor is ordered, delivered, and installed. Upgrading to a furnace with an ECM blower motor. The DOE's mandate that manufacturers install ECM motors in new furnaces.